Hello everyone and welcome to next video that we have here. We're going to be working with inverse functions. So those of you who watched the last video, we found some inverse functions, and in this video what we're going to be doing is we're going to be proving inverse functions. So if you want to know how to find them, you can go back and watch the last video. You can see the work for this last video on the screen here. What I want to do is get rid of all the work and just take a look at our two different sets of functions. All right, so we're going to have two different examples here, the f of x example and the g of x example. All right, so we'll put the g of x off to the side for now, and we'll take a look at just the f of x. So again, we're not finding them anymore. We found them last time. This time we want to prove that these are inverse functions. And the way we're going to do that is we're going to compose the two functions together. I want to find f of f inverse of x, and I want to find it in the opposite order, f inverse of f of x. And when you compose inverse functions together, you should get x as your composition function, and it should happen in both directions. If it doesn't, something went wrong. They are not inverse functions, so then you'd have to go back and redo everything. So let's take a look at what we have here. I'll change the inverse to a different color, maybe makes it a little easier for us. So I'm going to find f of f inverse of x, and we'll do this one first, and then we'll also find f inverse of f of x. So we're going to go ahead and compose these two together. So if you don't know how to compose functions, there's a video for that. You might want to go back. I think it's video 7 and 8, two different examples. So what we're going to do is we're going to have f, and I'm going to actually write what f inverse is, which is a negative x plus 17 over 8. Right? And what we're going to do is we're going to take function f, which is negative 8x, and anywhere I see x in its place, I'm going to put negative x plus 17 all over 8, and then plus 17. So in function f, I replaced x with f inverse, which was negative x plus 17 over 8. So what we're going to do now is we're going to simplify. So if I were to do this, we would distribute in the negative 8. So I would like to do this kind of a little differently. The way that I look at this is I know that this 8 is going to cancel with this 8 down here. Now you have to be careful. The one on the outside is a negative 8, so I actually know the negative is still going to be there, but the 8s are going to cancel with each other, and that denominator is going to turn to 1 and disappear. All right, so the 8 and the 8 cancel, leaving me with the negative that's out front. That's still going to be there, and the numerator on the inside, negative x plus 17, is still going to be there. So then what I want to do next is distribute this negative, so that gives me x minus 17 plus 17, and then minus 17 and plus 17 are going to cancel with each other and leaves me with just x. And so as you can see, we compose these two functions together, f of f inverse of x, and we ended up with x. So this does not prove that they are inverses yet, because I also have to compose it in the other direction. Right? So that's kind of half of the work we need to do. I'm going to now do the other half. And now I'm going to start with f inverse on the outside and put the f of x on the f inverse on the outside and the f of x on the inside. All right, so again, what I want to do is I'm going to rewrite this, and I'm going to replace f of x with what it actually is, which is negative 8x plus 17. All right, and I'm going to rewrite function f inverse, and anywhere I see x in parentheses, I'm going to write negative 8x plus 17. Right, so we're composing the functions in the other direction. I wrote the f inverse, and anywhere I saw the x in the f inverse, I wrote the function f. And now I need to simplify. So the first thing I'm going to do is distribute this negative into that set of parentheses, and that gives us 8x minus 17 plus 17 divided by 8. And then hopefully we recognize that plus 17 minus 17 is going to cancel out and give us 0. So we get 8x over 8. And then the 8's are going to cancel and turn to 1x or just x. All right, so as you can see, we compose these two functions in both directions, and both times we got x, so it looks like I actually found the right inverse in the other video. Now, we're going to go ahead and take a look at the other function that we have here, the g of x. So I'm going to need some more room. Kind of got a mess here. Let's see what we have. All right, so again, we need to compose this in both directions. I'm going to need to find g of g inverse of x and g inverse of g of x. And in both compositions, I should get back to x, or I did something wrong when I made the inverse. So in this case, g of g inverse, and g inverse is 3 over x plus 5. So then I'm going to rewrite the g function, which is 3 divided by x. But anywhere I see x, I'm going to write the inverse function, and then minus 5. Now, this may look a little confusing, and you don't know what to do here. If that's the case, then you could write it out as a long division. 3 divided by 3 over x plus 5 minus 5. All right, and we want to think of this as a fraction, so we'll think of 3 as 3 divided by 1. And then when we divide fractions, we flip and multiply. So I'm going to change it to multiplication and take the reciprocal of the fraction that's to the right of the division. And then I can multiply those together that way, so we get 3 times x plus 5 divided by 3. Okay, those 3's are going to cancel with each other, so that leaves us x plus 5 minus 5. Plus 5 minus 5 is 0, so they disappear, and it gives us x. All right, so again, you can't stop here. You got to compose it in both directions. Sometimes, if you compose it in one way, you'll get x, but then you compose in the other direction, you don't get x. Those are not inverse functions. So you got to make sure you do it both ways, or it doesn't really count. All right, so g inverse of g of x, and g of x is 3 over x minus 5. So I'm going to rewrite the inverse function, 3 divided by, and when I see x, I'm going to stop, and I'm going to put the g function, which is 3x minus 5, and then plus 5. All right, so I substituted in the g function, which was 3x minus 5, in for x in the inverse function. And now we're going to simplify and see if we get back to x. So in this case, we can see that the minus 5 and the plus 5 are going to cancel each other. That gives us 3 divided by 3 divided by x. Again, if you don't know how this works, you can think of it as long division. Not really long division, but next to each other, right? A little different than a fraction. And then when you're dividing fractions, you flip and multiply. And then multiplying straight across when you multiply fractions. 3x over 3. 3 divided by 3 is 1, which gives us 1x, which is just x. So in this case, I did find the correct inverse functions. They both compose to x, so we know this one is right. We proved that those are inverse functions. And for the f, we did the same thing.